All right, so we got the upper beginner level first. So find the positive number. I mean, that was free sugar, very easy, right? You got an array, there is a single argument, and we want to return a number with the result. So do you know in JavaScript which method can search something and return the matching element? Fine, that's correct, Lauren. So numbers dot find. Actually, I'm going to switch off my camera on Hangouts because it's very slow. Cool. So what I am, here we go. So numbers dot find, and I got number. And then if I want to return a positive one, can anyone tell me what else do I need to write here on the right hand side? That's correct. That's a really good point, Lauren. So the exercise is not telling anything about whether 0 is included as a positive number or not. So we got some sort of freedom, right? Will that work? What do you think? No, why not? That's correct, guys. There is missing return statement. And will we get any elegance warnings? The semicolon. That's correct, guys. That's correct. So if we run it, I think that should be pretty much it. There you go. Yeah, the answer is perfect. Any questions? No? Anyone else? No? Oh, cool. Thank you. Thank you. Question number 2. Get the last element. So I got an array. So the function receives a single argument, and I want to return the last element of the array. So can I do fruits of 2, for instance? So if I ask you what will be the color palette on the left-hand side, you got 2 assertions. They could become green or red. So what's going to be the output? It will be green, 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 red, red, green, or red, red. Green, green, red. So all right, Maxim thinks it's going to be fully green, right? So we're going to get confetti. However, green, red. All right, let's play it. That's correct, it's green, red. Why green, red? Because we are hard coding the last element of the array. That will only work if the array, out of coincidence, has 3 elements. However, as soon as the array has a different number of elements, that won't work. So, you know that in JavaScript you can get the last element of the array typing array.length. However, will that work? Sub -1. Why, Maxim? Can you defend? Let's imagine that you were in a job interview. So why -1? Yeah, but why? Why -1 and not -2 or -3 or? Can anyone help Maxim? That's correct. That's correct, Elena. Arrays start counting at 0 index. So if the length is 3, the last index is 0, 1, and 2. That's why we need to subtract 1 from the array. Any questions? No? All right, so let's do question number 3. How good a student am I? Oh, that's interesting. That question was not particularly complicated, but it was very easy to fail here because you got 4 different options. So we could 2 options. We can either use the ternary operator or we can use a classic if-else. I'm first of all gonna use the classic if-else. So with the classic if-else, I can do if first score is less than 50. And we'll run a workshop about Boolean operators next week. But that's the AND operator. So if these 2 expressions are met, so if first score is less than 50 and second score is also less than 50, then do something. Else, if, actually, let's complete that sequentially. So if both the scores are less than 50, return, what do I return here, guys? Need to improve, that's correct. Need to improve and the exclamation mark, yeah? And then else if. If, for instance, the second score is, actually, let's start with the first score. If first score is less than 50, first score is less than 50, can anyone tell me what I'm gonna return here on line number 5? Getting better. Why? That's correct. That's correct, Maxime. Getting better. But why getting better and not getting worse? Look, it's important to understand that piece of code, guys. So if both scores, yes, if both scores are less than 50, that's probably the simplest scenario, right? If both variables are below 50, need to improve. Then else if, look. Else if first score is less than 50. So can anyone tell me whether the second score, is it below 50 or above 50? It's above 50, that's correct. Because if it was below 50, then the code will stop here. Yeah? So else if means at least one of these conditions is not true. So if the first condition is true, that means that the second one will be false. So the second score will be at least 50, in which case we are going to display getting better. And now, can anyone tell me what's the next condition I'm going to write here? That's interesting, Elena. Yes, you're right. That's the other way around. So the thing is, in this case, both scores are below 50. If not, that means at least one of them is above 50. Is the first one the one that is below 50? If so, the second one will be above 50. On the other way around, if the first score was above 50, but the second one was below 50, the first condition won't be satisfied. It will jump here. If first score is above 50, the second condition won't be satisfied. In here, what we know is that the first score is above 50 and the second score is below 50. Okay? I know that's a bit confusing. You can obviously make that more complicated. You can compare, also you can do if first score is below 50 and second score is above 50. You can do that. It's just, to me, it's a bit redundant. Yeah, because that's something that is implicitly evaluated. But if you don't feel very comfortable with that if-else structure, you can actually run it in the long way. So you can actually do things like that, right? I hope that helps a bit on the readability, even though, once again, that is a bit redundant under my point of view. So getting worse. And eventually, can anyone tell me what else do I have to type here? Else? Do I have else if? Just else, because that's the final scenario possible, right? If we're still alive here, if the code is still running in this line number 9, that means that both scores are above 50. Not yes, right? This is just awesome with 4 exclamation marks, yeah? Something like that. Obviously, technically speaking, I can do that, right? I can do if first score is greater than 50, should be greater equal, right, guys? Don't take that as greater equal, but you get the point, right? Second score is greater than 50. So technically speaking, we can do that, yeah? And probably the code becomes a bit more readable. I mean, let's test it to see if it works first of all, right? So, all right, so second score, oh, there's some typo, right? Second score with capital C, what is that? Second score, line 2, oh, brilliant, thank you. And actually that's wrong as well, right? So should be second score Yeah, instead of first score. So we always compare first, second, first, second, first, second, first, second. Fair enough. So let's test it again. And then, oh, getting worse. There is a typo here, right? So my laptop is so small that I'm really struggling to type. All right, so let's see if it works this time. You see, you got confident time. So from an educational point of view, that's in my opinion, that's the best approach, because I believe that's very readable. Yeah, that's very readable, because you don't care about what happened before. You just focus on that particular bit, and you focus on that particular bit. However, as I said before, that's a bit redundant. I don't know. That feels a bit unnecessary. Because for instance, so here we can remove the first bit. Then we can remove the other bit, and then we don't need the else. So we don't need the else if, something like that. Yeah. So I believe, and we can review that in a second, that will generate the same output. So if both scores are below 50, need to improve. Else if second score is below 50, yeah, that means, so it's above 50, that means the first one will be below, we're getting better. On the other way around, if the second score was below 50, we are getting worse, I think, something like that. All right, so I did something wrong somewhere. Let's try to find it out. So yeah, so that line is never running because that should be on the other way around. That should be first score should be greater than 50, I believe. Let me run it, and then we'll. That's the great first score. Wait a minute. What I'm doing wrong? Getting better. So if both scores are below 50, need to improve. Else, if the second score is above 50, that means the first one was below 50, getting better. That's correct. The problem is when both scores are above 50. So if second score is actually, let me, you see, I'm getting confused now, and I'm getting confused because even though I'm trying to create a more performant solution, it is way less readable. Because I really need to get control on the whole picture to understand what's going on. Whenever that happens, what I used to do is I used to start from scratch. Yeah, I find that particularly interesting towards solving the problem, because otherwise I'm sometimes turning around the same problem. So let me think about the problem from scratch. So the first use case scenario, it's obvious, right? If both the scores are below 50, then you need to improve. However, if the first score, however, was less than 50, sorry guys, you know what? I'm gonna give up. I'm not gonna explain that now because this is. In which line, Elena? Yeah. Mm-hmm. Yeah, absolutely. So the second one could be bigger than 50. Yeah, that's absolutely correct. So yeah, well, the thing is now it's in the middle of nowhere, right? Because we've got a big mess. So that's fine, guys. I think it's a very healthy exercise, but rather than giving up, what I would like to do is I'm gonna start again, right? I mean, the first condition is crystal clear. You know how to solve it with a long way, yeah? Comparing first score and second score all the time. That's fine. It will work, no problem at all. However, let's try to find a way to solve it with using the shorter version. So what we got here is. If both scores are less than 50, then you need to improve. What else can we check here? Yeah, if first score. Yeah, that's what I wanted to do actually. You see, because I'm starting again now with some fresh air. To me, it feels much simpler to find the solution. Yeah. So what happened here? If the first score is less than 50, yeah, that means that the second one is going to be what? Above or below 50? It would be above, absolutely, because if it was below, it will be captured by that bit, right? So the first score is below, but the second one is above. In this particular case, we will return getting better, right? Because the second score is above 50 and the first one is below 50, so getting better. And now next step is probably the most complicated one, if it's on the other way around. Else, if second score was below 50, then that means that the first one was what? Above or below? Say it again, sorry. Above, yes, because if it was below, once again, it will have been captured by the first one. So what we know implicitly, and that's why that's a bit more complicated to read. It's probably more efficient from a machine point of view because we need to mess around with less variables. However, from a human point of view, I hope you agree with me, that's a bit more complicated because you really need to follow the sequence from the beginning to understand what's going on, right? So in this particular case, we're getting wash, clearly, right? And finally, else, if we're still alive on line number 9, what we know is that both scores were above 50, in which case we will return just awesome. Something like that. What do you think, guys? Will this work this time? All right, let's try it. Yes, you see, it works this time. So, once again, pros and cons. So, the code I wrote first, comparing first and second every time, was better for humans from a readability point of view, but I would say it's less elegant. And this is on the other way around. That's probably a bit harder to read, easier to mess around, but at some point, it's technically speaking, more appropriate, I would say. Yeah. Of course, we could write a ternary operator if you want. So we could do return. I'm gonna do some copy pasting. So if both the scores are less than 50, need to improve. Else, if the first score is less than 50, getting better. Be careful with the indentation, guys, because indentation here is vital to have something readable, yeah? Readable-ish. Getting worse. And eventually, let me try to indent that correctly. There you go. And eventually, just awesome, as you can see here. So, I mean, let me remove the part at the bottom. Let's prove if it works, right? And if it works, then we'll compare them. All right, so parsing and expecting, yes, awesome. Right, I forgot the colon here, right? It was a silly typo. And then you see it works. So now the question is, which approach do you prefer? Do you prefer the if-else approach, or do you prefer the ternary approach? Why? Hmm. Hmm. Okay. Okay. Yeah. Fair enough. Fair enough. Yeah, I'm not massively opinionated. I mostly agree with you that the ternary operator works a bit better. However, once again, be careful because the ternary operator works better when the expressions are simpler. Yeah? At some point, if we will have to deal with 27 conditions, if else, if at some point, ternary operator will be a big mess. So nothing is right or wrong. That depends on the person. The important thing is at least be able to argue. The wrong thing, the wrong answer here is I prefer the ternary operator. Why? I don't know why. Right? That's not a valid answer. As far as you can defend your theory, your strategy, that's all good. Anything else, guys? So once again, you've seen that I struggle a bit with that problem, which is weird because that's a very simple one. However, I'm really happy about that because that sometimes happen, especially when you're in a job interview. You may be dealing with a very simplistic problem, but because of whatever reason you don't have your day, whatever. I think it's important to face the situation, and as I've done today. So if something doesn't work and I keep adding changes, doesn't work, I'm doing some sort of a snowball effect, when I'm making the problem worse and worse and worse. That's why at some point I think it's important to get rid of everything, start again, and you'll see how everything looks much easier, much simpler than it was at some point. Cool, that was the question number 2. That's a piece of cake, guys. I'm not gonna do that one, that's so simple. Does anyone, guys, has any question about this particular exercise? All right, so I'm gonna skip it. If any of you has any questions, 2 things. First of all, go back to the code, go back to the challenge and review the code that your colleagues wrote. And if that's not enough, of course, let me know on Slack. That's very interesting. Reduce. Brilliant. Find the highest number. We'll be running a workshop about reduce. However, I think there is a good opportunity to review it. I think we've never explicitly referred to it before, so now we got a good chance to play with it a bit. So what reduce is? Reduce is one of the most powerful methods in JavaScript, and it essentially loops over an array of elements, and then it returns something, whatever we want on its iteration. Whatever reduce returns on iteration I, it will be the input on iteration I plus 1. So we keep passing the value over and over and over. I'm not gonna solve this exercise now, guys. I'm gonna show you a more simplistic use case scenario. Imagine that I wanna add multiple numbers. Yeah, I have a list of numbers, 1, 2, 3. Let me actually call it numbers. There you go. And now, based on that, I wanna do something. I wanna add them all, right? So, for instance, if I call add with an array of 1, 2, and 3, that should obviously return eventually number 6. Yep. 1 plus 2 plus 3 equals 6. All right. So there are obviously multiple ways of solving the problem. I could use for each. I could use a for loop. However, let's pay attention to how powerful reduce is. So with reduce, we can type. Let me type the code, and now we'll explain what are we doing. So numbers.reduce, and then I got numbers, or let me rename that to total, and then number. Sorry, it's very complicated, guys, because there is a delay of maybe 1 or 2 seconds between my keystrokes and the result, but we'll sort it out. All right, so yeah, that's what I wanted to build. Look, let's try to understand it. So with reduce, we have, generally speaking, at least 2 arguments. The first argument is what we call the accumulator. The accumulator is what we return on the previous iteration. And what happened on the first one? On the first iteration, there is no previous iteration. So the accumulator is initialized to whatever we pass here in this argument. Yeah? So my default total value will be 0. And then you got the number. So the number represents each individual element in the array. So let's play a game. I'm going to refer to this technique often, and obviously I would like to invite you to follow it as well. So look, on iteration number 1, let me try to add some notes. So for instance, I got a question for Max. So Max, do you know what's the first value of the total? Yeah, of course, Maxim. It's going to be 3. Why 3? Right. Wait. Sorry. I need to do a timeout here. That's not correct, Maxim. That's not correct. So the first value of total is not 3. So, Vicky, do you know what's the first value of the total? No. Ignore the left-hand side. Just focus on the right-hand side, please. The total is 6 on the first iteration. All right? That's not correct, Vicky. Wait. So let's let others participate. So Elena, do you know what's the value on the first iteration for the total? Ah, that's correct, Elena. That's correct. It is 0 because, once again, on the first iteration, the very first time we stop on line number 3, remember total refers to what we return on the previous iteration. On the first one, there is no previous iteration. That's why we pass that number here. So that's going to be the default value of the total. And now, I got a question for Elia. Are you connected, Elia? I'll take that as a no. Here I'm tracking Max, Lauren, Vicky, Maxim, Elena, and that's it. Is anyone else connected? Anyone else I didn't mention? Aaron, sorry, Aaron, of course, Aaron. So Aaron, do you know what's the first number? One. Why 1? That's correct, my friend. That's absolutely right. Yeah. So on the first iteration, number will refer to 1. So, and then I got the question for Max. What do we return on the first iteration, Max? Why 1? Is the number that is found on the first iteration. So, well, I mean, the answer is right, but the thing is, it returns 1 because we are returning the result of adding the total, 0, plus the number, 1. So we return 1. And then we go to iteration number 2, and that's a question for Lauren. So, Lauren, can you tell me what's the value of the variable total on the second iteration? Yes. Why 1? Yeah. That's correct, Lauren. So we are essentially returning 1 on iteration number 1. So that's what gets passed to the next iteration. Yeah. So, and then there's a question for Vicky. What's the number on iteration number 2? It is 2, right? Because that's the second element of the array. That's correct. So now a question for Maxim. What do we return at the end of the second iteration? 3. Why 3? Yeah, that's absolutely right. So it's 3. Yeah. So now on the third iteration. So question for Elena. What's the total so far? Correct. And what's the number question for Aaron? Yeah, that's correct because this is the last number. So eventually, what do we return, Max? 6. That's correct. And then what happened on iteration number 4, Lauren? What's the total? Are you sure? All right. And what's the number? Lauren, I keep playing with you. What's the number? So what? That's correct. The question was a trap. I will ask that many times. There is no iteration number 4, right? Because we're in the end of the loop, right? There are 3 items, 3 iterations, that's it. So that value, the last one, that's the eventual result of the algorithm. Yeah? Number 6. That's the way you can easily add all the elements of an array. And of course, you can simplify the expression by, because you are already familiar with that coding structure, by doing something like that. Yeah? One line. That's essentially the same thing. Questions about reduce? So I said, yeah, I mean, if you want to add some numbers, by default, what's the default number? If I want to check how much money I have in my pocket, by default, how much money do I have? I have got 0, right? I mean, you can put whatever you want here. Can anyone tell me what will this algorithm return if I initialize the accumulator, the total variable, to -1? It will return 5, eh? Correct, it will return 5 because by default total will be -1, so it will add all the numbers that are starting from -1. So that obviously depends on what you wanna do, right? In the future, in the workshop, we'll talk about more advanced use cases scenarios where we can initialize the accumulator to something different apart from a number, like an array or an object or whatever, yeah? But just talking about the most simplistic use cases scenario, and that's actually the most simplistic use cases scenario I can think about, just adding some numbers in a list. You know, the default is 0. What else, guys? A string, well, here in the accumulator, so you want to type Maxim here. Using a string like that. Well, I mean, comma string, I'm not following. Number colon string. That, like that, Maxim. Quotes. It's not, that has nothing to do with your English. That's about your ability to express, and that's important. Remove the number. Okay, remove the number. Let me give me a second. So I'm removing the number. Yeah. Like that. But that doesn't make sense, my friend, because here we got a what we call a callback function. And in this function, you have 2 arguments. So you need to type the argument names. Other question is, if, and that's a good question, can I rename number with Brexit? Yeah, I agree on that. You definitely can. I mean, you can do whatever you want. This is just the name of the variable, right? Can I call it Boris? Of course I can, right? If I run that's gonna work. That's gonna work. The important thing here is the first argument, that's the accumulator. That's where we hold, that's the basket where we hold the intermediate returns values. And the second one is represented by each element on the array. Obviously, feels a bit weird, right? So, yeah. Reduce, no. Reduce can be used with any type of operations. Actually, personally, reduce is probably my favorite method in JavaScript because you got so much freedom. We'll see how to use reduce and how can I perform any type of operations with JavaScript data. So it's not just about numbers. Don't worry about that. Yep, the second, correct. The second element represents each element on the array for every iteration, right? So how many times, if I could add breakpoints, guys, on line number 2 and 3, yeah, imagine we got two breakpoints, one in line number 2, one in line number 3. Can anyone tell me what's going to be the execution order? Vicky? What you said? Yeah? What do you think, guys? That's no. So one of the beautiful things about modern JavaScript, reduce was introduced in 2015, so it's a relatively new method, is that it works very similar to find, filter, and all these other methods, right? It's pretty much the same thing. So numbers.find, numbers.filter, numbers.reduce, and then you got a callback function, and then you do something as part of the callback function. The main difference is, so far, what we learned with find, filter, and map, we use, generally speaking, a single argument, right? We do that. So the first argument represents each element of the array. However, now with reduce, we got a new argument. The new argument, the first one, is the basket where we are filling whatever we want to eventually return. Questions? Right, I'm gonna do something, guys. I'm gonna share that algorithm on Slack. So we're gonna run few workshops about reduce. Don't worry. To me, reduce makes the difference between a really good developer and a bad developer. So it's vital to really practice and get used to it. So for now, I've shared this snippet with you on Slack, and of course now it's up to you to go to Playground and add breakpoints and play and all these things, right? Try to change the algorithm a bit, all these sort of things. So that's the basics about reduce. However, that's not what we had to do, right? This exercise was slightly different. So on the exercise, we had to do something slightly different. We had to find the highest number. So we are using reduce, or the exercise is inviting you to use reduce. Personally, I wouldn't use reduce. If I would have to write this exercise from scratch, I would use a different technique. But once again, I think it's important to play with snippets that you don't feel very comfortable dealing with, right? Because that gives you some resilience of, this movie, these Hollywood actors, that they are playing the same role in every single movie. I'm thinking about Adam Sandler. He's always running the same movies again. He's like the childish man, blah, blah, blah. And then suddenly, he was to play a different role, to play, I don't know, like being part of a drama movie, because otherwise, you're doing the same thing all the time, right? So that's pretty much the same thing. I don't want to play a comedy movie. I want to play a drama movie, right? Role. So, look, that's interesting. So we got two arguments, highest and number. So what I'm going to do is, look, if number is if number is greater than highest, can type it, then return number. Else, return highest. Or we can do a ternary instead. Return number greater than highest, then number else highest. So now, let's create our matrix of execution, right? Execution matrix. So iteration number 1. There is an important difference with the previous example. Can anyone see where the main difference is? But that shouldn't be a problem, right? That should be okay, right? That the algorithms we're dealing with should be smart enough to deal with either. But that's fine. That once again, that's the same we've done before. We can deal with that, Vicky. That's not going to be a problem. However, we'll find out. Yeah. That's interesting, Aaron. Actually, question for you, Aaron. Can you tell me, Aaron, what's the first value of the accumulator, the first value of highest? Let's focus on the first example on the left, yeah? 13. That's not correct. That equals 13, that's the expected outcome of this algorithm. Eventually, it should return 13 because within that list of numbers, 13 is the greatest one. But that's not the first value of the accumulator. It will be 2. Why 2, Aaron? But that's not what we learned before. What we learned before it was 0. Why can anyone tell me why before it was 0? That's not correct. That's not correct. That's absolutely wrong. Guys, please check Slack. I'm not going to tell you the answer. If no one gives me a right answer, I will switch off everything here. So Elena got the jackpot. On the previous example, we passed an argument here, was comma 0. Oops, not comma minus, comma 0. However, do we have any comma 0? No. I mean, we could definitely do something here if we wanted, but the exercise is not putting any value in there. So what happened? What happened if there is no default value? No. If there is no default value, if I put here Boris, the first value of highest will be Boris. However, if I don't provide any value, then the initial value of highest will be the first element of the array. So it will be 2. And now I got a question for Max. What's the first number? Is it 2? Or not? What do you think, guys? That's not correct, I'm afraid. That's not correct, because otherwise, what was the point? So are we having the same number twice? No. So if that's correct, Aaron, that's correct. If the first value of the array is assigned to the accumulator, then the first number will be the next one, will be number 6. Yeah. Exactly. Yeah, that's exactly, it will count for there. So as you can see, we're saving one iteration before. All right, so in this case, can you ignoring the result? So let's talk about breakpoints. Wait, give me a second, sorry. So let's add some breakpoints and then you ask the question. So I got a breakpoint on line number 2 and I got a breakpoint on line number 3. So can anyone tell me what's going to be the execution order? How many 3s? 4? But we got 5 elements in the array. So why 4 times? That's it runs 4 times on line number 3 because we are saving one iteration. Yeah, we are saving the first iteration because we don't have any default value. However, if we were adding a default value, then we will run 5 iterations. Yeah. So that's a subtle but important detail. And now, Max, back to you. I think you got a question before, right? Mhm. Okay, cool. Great stuff, great stuff. I mean, once again, guys, I'm not asking you to fully understand everything. We're going to run at least one workshop about reduce because that's very important, right? But at least that should start sounding familiar in your head. All right, so question for Lauren. What do we return after the first iteration? Y6? That's correct, Lauren. So now iteration number 2, question for Vicky. What's the value of highest? Then Maxim? Elena? Y? That's correct, guys. The rule is pretty simple. Whatever we return in one iteration becomes the next highest, the next accumulator, the next first argument, how you want to call it. Yeah, so that's correct. So now, question for Aaron. What's the next number? 1, correct, because that's the next one in the list. So what do we return, Max? 7. Why 7? Total, but we're not doing anything with the total. That was the previous exercise. That has nothing to do with the total. Why 6, Maxim? That's correct. We're comparing 6 against 1. So we have 6. So what happened on iteration number 3, Lauren? What's the highest? That's correct. We passed 6 to the next iteration. So what's the next number? Who's next? Vicky. 9. That's correct. It's 9. And what do we... Wait. Maxim, what do we return? Why 9? That's correct. Brilliant, guys. You see, once you repeat it, eventually it makes sense, right? So iteration number 4. Question for Elena. What's the highest? It is 9. Correct. So now question for Aaron. What's the number? 13. That's correct. So now question for Max. What do we return? 13. That's correct. And now question for Lauren. Iteration number 5. What's the highest? Correct. Brilliant. She wasn't caught by the trap this time. Cool. That's correct. There is nothing, guys. There is nothing. We end on at the end of iteration number 4. So eventually, that will say that that returns 13. Yeah. And yeah. Well, first of all let's make sure it works, and then we'll play with fireworks. You see? So that's correct. It works. And then let me share it. This is going to be the last exercise we're reviewing today. I wasn't honestly planning to invest so much time on reduce, but this is so important that we need to spend as much time as necessary. And I got a question for you. What happened? I'm still on the first use case scenario, right? If I put this, my default value is 100. What's that gonna return eventually? $100. That's correct, because we'll be comparing each individual element against 100, and 100 will be the maximum one, right? And what happened? Will it work if I initialize it to 0? It will in all the use cases scenarios. Not if all the numbers are negative. Why not, Lauren? That's correct. You see, it works in all the use cases scenarios because in all the assertions we got at least one positive number. However, in the last one, we don't have any positive numbers. In other words, 0. Is 0 greater than -6? Yes. Is 0 greater than -1? Yes. So it will return 0, which is not correct. So can we, imagine that, I mean, to me, the best solution is don't put any value, don't put any default value. and then the algorithm is perfect. But imagine that because of whatever dark, obscure, bizarre reason, we need to put a value here. Yeah, the employee is asking us, what if there was a requirement to put a value here? What would you do? Which number would you put here? Zero? But that's not going to work, Maxim. -1? But, all right, with -1 it works, but as soon as you get different data, as soon as you get a number, another array with -4 and -7, that's not going to work. But once again, that's not going to work. That's not... Yeah, Maxim, sorry. Let's ignore the left-hand side. I don't care about the left-hand side. I want to write an algorithm that, given a list of numbers, tells me the highest one. And it should be strong enough to adapt itself to any use case scenario. Okay. I'll tell you something. I wasn't thinking about that, but that's actually a good idea. So if here you pass numbers of 0, you see, that's a trick. But, it works because, yeah, all the numbers will be part of the list. That's okay. That's a good idea. Any alternative? The word highest, that's not going to work because highest only makes sense inside of this function. So this is going to throw a what? Number, like that, number, that's not going to work. This is the same as typing Brexit. So it's outside. There is no variable called number. No, that doesn't make sense because then we are comparing the highest, so whatever the number is, against an array. So that's not going to work. So that's a good point, actually. But no, but we don't know. That's the point. That's the point, Max. We don't know anything. So the algorithm should work perfectly regardless of what the data is. That's a classic job interview question. So then you can say, all right, so first of all, do that, right? Without any default value. So the first highest will be the first value of the array. It will work regardless of what the list of numbers is. And what Lena suggested was right as well. Initialize it to the first value, and then it will work as well. Let me show you a different way of solving the problem. That's a bit advanced, but this is one of the things that will give you some programming culture. In JavaScript, there is something called JavaScript min number. In other words, I mean, I could be tempted to type -1 million, right? But you see, that's quite dirty, because that will probably work fine in many of the cases. But at some point, what if we got a number lower than that? So can I type -1 trillion or something like that? That's dirty. That's not going to work eventually, because at some point, the number you can write here will be beyond the ability of your 64-bit computer machine to proceed, right? So at some point this is going to blow up. So no, don't do that. Don't do that. However, in JavaScript, there is something. No, not min value, because I will return the number. No, not that one. There is another method called min safe integer. Oh, sorry guys. I'm trying to type. I promise. Min safe integer. That one. Look. The number.minSafe integer constant represents the minimum safe integer in JavaScript. Look at the number. I don't really care about what that number is, but the thing is, there is nothing below that number in JavaScript. So, if there is nothing below that number, technically speaking, we could do that. Yeah. Once again, that was a bit probably unexpected, but this is one of the things that will give you some sort of programming background, right? So in JavaScript, there is a way to get the minimum value possible. Yeah? And of course, imagine that in reality, we want to do the other way around. We want to get, instead of get the highest, get the minimum number. So can anyone tell me what do I need to change? And what else? That's correct. From readability point of view, that's not the highest, that's the lowest, right? And now, what here, first of all, we can, as we've done before, we can leave it like that, right? We can pass the first element of the array, or we can pass the number dot, what I am, mean, not the mean, but that should be on the other way around, right? Now I want to initialize it to the maximum number possible in JavaScript. So that's obviously not going to work because the exercise was you to build something different. But just for testing purposes, you'll see if I run it, can anyone tell me what the first assertion will return? 1, that's correct because that's the minimum number. So if I actually, sorry, I forgot to rename that variable. Sorry, that's my fault. So let me run it again. And if I run it, where is it? Am I running it? Let me test it. Ah, that's interesting. So that's not actually working. And, of course, no, sorry. So I need to rename the function name. Yeah. So I went too far. With my changes. Yeah, you see, as soon as I use the same function name, you see, now my algorithm is always returning, instead of the maximum number, is now returning the minimum number in that list. Questions? Like that? Yeah, no, that's right. I mean, if both the number and the lowest are the same, if I got 4 and 4, then who cares, right? It's the same number. So who cares if it wins this one or that one? It's the same number, so that's fine. Where, and here, that's a bit dirty in terms of my point of view, because you're at some point comparing number, which is 1, 2, 3, 4, 5, whatever, is 4 less than undefined. I don't know. So the thing is, we should always play with numbers if that's what we want to do, right? We want to compare numbers, so let's initialize it to a number. It's like what happens if I pass an object? I don't know. That's weird. That doesn't make sense to me. Anything else, guys? Nothing. All right. So reduce, right? Yeah, definitely. This is practice, and practice. And please write down the matrix I showed you before. Remember iteration, blah blah blah, because I think that helps a lot to visualize the shape of the exercise. Cool. That was it from my side, guys. I'll see you again at half 3 to cover the board challenge of the week. So thank you very much, guys, and see you later.